In this problem, we have cylinder at point A, and it travels to point B due to a force pulling on a rope here. And initially, this is at 0. We're going to identify this as 0. So then, R is this distance, but we also have to take into consideration the distance at which this rope travels, that vertical distance. And we can calculate that fairly easy, and I'll show you that in a second. But I want to focus on the concepts that we're looking at in this problem. We're looking at the method of conservation of energy. And this material is not going to be on exam 3, but it will be on the final. And the equation for that is the potential energy, TA minus TB, plus the kinetic energy, minus B. And all of that equals 0 because the change in energy in this problem equals 0. So all we have to do is identify what each of these are, and then we can move forward. TA is 0 because the velocity when it is at point A is 0. And the TB, that is going to encompass the velocity of B, so that will have our unknown. All we have left to do is calculate the potential energy of A minus B. So taking a look at this rope, the distance of the rope from A to the pulley is RH for hypotenuse, but the leftover rope, once it's traveled its complete distance, is R over 2. So at point 1, or point A, it is the entire rope. But after it gets to point B, there is a certain amount of rope that it's traveled this distance, and that is RH minus R over 2, because there is R over 2 rope here. And because we know that force P is acting on this rope, we can identify that potential energy as P times RH minus R over 2. Then we have our classic, let's move this down. Then we have our classic MGH, and instead of H, we have the distance of R, this complete distance from A to B. And that's negative because we've set our datum to A. Equals 1/2 mvb squared. And this is our unknown. We have all these identified. This here, I've calculated to be, where is that? 0.618 R. So we can plug that in to this here. P is 20 newtons times 0.618, and my R is 1.6 meters, times M, which is 0.8 times 9.81, times R, which is 1.6. And that is equal to 1/2 mv squared, and my M is 0.8 VB squared. Solving for VB, we get that it is a total velocity of 4.25 meters per second. And given the energy information, that cylinder is sliding at 4.25 meters